All right, let's talk about something that feels a little like magic. How can an AI do what seems like a full day's worth of work in just a few seconds? Well, today, we're going to pull back the curtain on that secret. It's all about a really powerful design concept called the parallelization pattern.
I mean, seriously, how is that even possible? Picture this. You ask an AI to research 3 totally different, complex topics. Let's say renewable energy, the latest in electric vehicles, and carbon capture technology. And then, not just research them, but write a comprehensive report on all 3. And it does it all in the time it takes you to grab a coffee. It really does feel like magic, but it's not. It's just a classic case of working smarter, not harder.
Okay, so to really get this, let's start with the way we usually think about tackling a big project. You know, the logical step-by-step approach. We're talking about the sequential slowdown.
So you tell your agent, okay, research topic A. It does it. Then what? It just waits. It sits there, doing nothing, until it gets the green light to start topic B. Then it finishes B, and yep, it waits again before it can even think about starting C. Each one of those pauses, those wait moments, is a massive bottleneck. The clock is just ticking, and the total time just keeps piling up.
And here's the kicker. The total time it takes is the sum of all those individual steps. The analogy here is perfect. It's a traffic jam for your AI. Imagine a single-lane highway during rush hour. It doesn't matter if you're driving a Ferrari, you're still stuck behind the slow car in front of you. That's exactly what's happening here. It's a total performance nightmare and just so inefficient.
But what if we could just add more lanes to that highway? What if we could blow that traffic jam wide open? Well, this is the aha moment. This is the parallel breakthrough. It's the real secret to that incredible speed we were talking about.
So, the official name for this trick is the parallelization pattern. And what is it really? It's just a method of running multiple independent tasks all at the same time. And that word independent is absolutely crucial. See, the research on renewable energy doesn't need to know anything about the electric vehicle research. They're separate jobs. So why on earth would we make them wait for each other?
And this chart just lays it out perfectly. Look at that top row, the sequential one. It's like a relay race, right? One person runs, hands off the baton. Then the next person runs. It's execute, wait, execute, wait. But now look at the parallel row. That's not a relay race. That's the 100-meter dash. All the runners start at the exact same time. Execute, 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 all at once. And suddenly, the total time isn't all of them added together. It's just the time it takes for the slowest task to finish. That is a game changer.
Okay, so this isn't just some abstract theoretical idea. This stuff has huge real-world implications. So let's talk about parallelism in practice. Where does this pattern actually make a difference?
Well, a perfect use case is information gathering. Let's say you want your agent to build a profile on a company. The old way, it would check the news articles, then it would pull the latest stock data, then it would query your company's internal databases. But with parallelization, it does all of it. News, stocks, databases, even social media mentions, all at the exact same time. You get this complete 360-degree view, but in a tiny fraction of the time.
And it's not just for gathering info, it's for analysis and content creation too. Think about it. An agent could be running sentiment analysis on customer reviews while it's also extracting the key topics from those reviews. Or even better, imagine drafting a marketing email. You could have one process generating catchy subject lines, another one drafting the email body, and a third one creating the perfect call to action button text. All of it happening at once. It just completely revolutionizes the speed of creation.
Okay, so this all sounds great, but how do you actually build an agent like this? Let's pop the hood for a second and take a look at the blueprint for a faster agent. This is a conceptual look, kind of inspired by how frameworks like Google's Agent Development Kit handle this problem.
First things first, you have to break the big problem down into smaller, bite-sized pieces. So instead of having one giant agent that tries to do everything, you create a team of specialists. Think of them as individual researcher agents. Each one gets a single, focused job to do. One is an expert on topic A, another on topic B, and a third on topic C. Simple. But you need someone to manage these specialists, right? That's where the parallel agent comes in. Think of this agent as the project manager or the conductor of an orchestra. Its one and only job is to kick off all those little researcher agents and have them run at the same time. It basically says, ready, set, go, to everyone at once. Okay, so now all your researchers have finished their work. You've got 3 separate piles of information. What now? Well, you need one more specialist, the synthesizer agent. This agent's job is to take all those different results and weave them together into one single, coherent report. It's the one that puts all the puzzle pieces together to show you the final picture.
So let's just quickly recap that three-step process. Step 1, dispatch. You send out all your specialist agents in parallel. Step 2, execute. They all go off and do their own independent research at the same time. And step 3, synthesize. A final agent comes in and combines everything into that one beautiful report. It's a really elegant and honestly, super powerful way to work.
All right, so why are we spending all this time on this one pattern? What's the big deal here? It's because this represents a really fundamental shift in how we think about building AI. It's the move from just working harder to actually working smarter.
I mean, when you put them side by side, the choice is just obvious. On the left, you've got the old sequential way, inefficient, slow, choked with bottlenecks. And on the right, you have the parallel workflow, efficient, fast, low latency, and super responsive. You're not just reducing the wait time, you're basically eliminating it.
And hey, don't just take my word for it. The source material we're drawing from really hammers this point home. It says, and I quote, "The parallelization pattern is vital for improving the efficiency and responsiveness of agentic systems." That word, vital, says it all. This isn't just a nice to have, it's a foundational piece for building top-tier AI.
So, I'll leave you with this question. The next time you're designing a system or giving an AI a complex job, just pause and ask yourself, my AI is definitely working hard, but is it working smarter? Because that one question could be the difference between waiting around for an answer and getting it instantly. Thanks for tuning in.